Good morning, students. Once again, I told you that I will take a class, and based on what we've done before, we've treated matrices, the types of matrices with copious examples and definition of matrices given, and I did promise that we will be discussing operations on matrices in a subsequent class. And today I have already prepared on operations on matrices, which is going to strictly be on multiplication, subtraction, and addition, where we will not discuss division as such, as already prepared in the class manual already sent to you. You will see that division in its sense, not that we do not divide matrices, but what happens is we take care of its inverse. If we have A divided by B, then we are trying to say A multiplied by B raised to power minus 1. So is another topic entirely when we want to take the inverse of a matrix. So taking the inverse of a matrix is another thing entirely. But going through addition, subtraction, and multiplication of matrices. The addition of matrices, you can add two matrices together when they must be of the same order. If A is of order 2 by 2, then B must be of order 2 by 2 for us to add the Aij's and the Bij's, the elements in the matrix A and in matrix B. Essentially, we can have that in example which is already given in page 2 of the lecture notes sent to you, and you can equally do the same thing with respect to the subtraction, of course. But you must know that subtraction is not commutative, but addition is commutative, in the sense that if we take matrix A and we add it with matrix B, you will see that matrix A and B will give you the same thing with adding B plus A. But in the terms of subtraction, matrix A minus B is not equal to B minus A. Hence, we say it is not commutative. That apart, we will see that example given for a 3 by 2 matrix and another 3 by 2 matrix. Of course, you can add together, but you cannot subtract a 2 by 3 matrix from a 3 by 2 matrix because they are not of the same order. And this has been demonstrated in the example 2.1b sent in the manual, which you can see that if you find A minus B, you are not going to get B minus A, and that which is quite clear enough. Then lastly, the point which we want to see is on multiplication of matrices, where I discussed the scalar multiplication of matrix, where we have K to be a scalar. Then if K is a scalar and you are given a matrix B or you are given a matrix A, then you take the scalar K to multiply across all the elements in the matrix A. Then you have KA11, KA12, dot 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 up to KAMN if A is an M by N matrix. Then it is very easy. You can use either negative, positive, scale, whatever. Even once its K is real number, positive integer, negative integer, fraction, whatever, you can use that as your scalar. Then multiplication of matrices. You can multiply matrix. Yes, this we can see if A and B are real matrices, then AB is not equal to BA, even though we know that multiplication itself, it's of real numbers, are commutative. 2 times 3 is equal to 3 times 2. But in terms of matrices, AB is not essentially equal to BA, and this we have demonstrated. And while doing that, you take the row of A to multiply by B, and you must note that, which I put in the lecture notes, that the number of columns of the first matrix must be equal to the number of columns in the of rows. Number of columns in the first matrix must be equal to the number of columns of rows in the other one. So if what you have to multiply, you cannot see that the column number, if this is 3 and the other one must be 3, otherwise the column here must not be 3 while the row, the number of row in the other must be 2, then you are not going to get a result. So this has been demonstrated, and you can see those examples which have been expressly put. Please go through, and if you have problems, please kindly let me know. I have received responses from some of the students this morning who have sent messages to me. Please kindly, let's just get that and revert. Thank you and enjoy your day.